We're given two functions f and g defined over restricted domains. We're asked, first of all, to explain why fg cannot be formed as a composite function. So what that means is we find g of x first, and then we put that into f of x, essentially. So what I'm going to do here is I'm going to think about the ranges of the functions. So for f of x equals 2 square root 1 minus e to the minus x, well, x is greater or equal to 0. So if x is equal to 0, then we're going to get 0 here for f of x. And then what happens as x gets bigger? Well, e to the minus x is actually going to get smaller. So the function itself is going to get bigger until e to the minus x. As x approaches infinity, then e to the minus x approaches 0, which would give us 2. So what I'm trying to say is that we've got 0 less than or equal to f of x. It can equal 0, but then it has to be less than 2 because it can never actually get to 2. So I just want to give a bit of reasoning. F of 0, I mean, this is only 2 marks, but I think it's useful to discuss. F of 0 is 0, and as x tends to infinity, f of x tends to 2, and it's going to be an increasing function. It's not going to like go up and down or anything. Let's now take a look at ln, or the range of g of x, to be fair. So if x is 0, then I'm going to get ln 4, but that's actually going to be the maximum value because this thing here is always greater or equal to 0. So g of x is going to be less than or equal to ln 4. Now, is there a minimum value? Because if we can actually we can never actually equal 2, but if we have ln of 4 minus something very, very close to 2, or as close as we want to 2, then we're going to get ln of like 4 minus 3.999. And this is going to be, this is going to be very large and negative. It's going to be less than 0, and it's going to be large and negative. And actually, we can approach minus infinity, I think. We never get there, but we can approach it. So g of x has to be less than or equal to ln 4, and those are our two ranges of the functions. So if we now think about f of g of x, we've got our set of x here for the domain of g of x, and it's going to be minus 2 less than x less than 2. And then we're going to map onto g of x, which is going to give us as our output all values that are less than or equal to ln x. Now the thing is, we're then going to map that onto f of x. However, the domain of f of x has to have x is greater or equal to 0, and we've just had here some possible negative values. So this has taken a bit of time, and of course you can do this more quickly, but basically the domain, sorry, not the domain, apologies, the range of g of x is not contained in the domain of f of x. So not possible to form f of g of x. Another way of saying this is that we can get some negative values from g of x, which then we cannot put into f of x because it's not allowed by the domain. If, however, we look at, so that's the answer to part 1. If, however, we look at g of f, then there's not the same issue because we've got this restricted domain of x. Let me actually draw it out again. So x has to be greater or equal to 0. This maps on to f, which is now between 0 and 2. which is contained in the domain of g of x. So we're okay. So the range of f is contained in the domain of g. So we can form g of f of x. So as long as you write the bits in red or words to that effect, then you're okay. But I've gone into some depth in finding the range, and I think that's pretty comprehensive then. On to part B. We're asked to actually find g of f of x, which will be g of, remember, f of x is 2 square root 1 minus e to the minus x. So I'm going to replace all of my x's in g of x by this thing here. So it will equal ln of 4 minus, and then 2 square root 1 minus e to the minus x all squared. Okay, we're not interested in the domain and range at the moment. Actually, I've already found them. So this will equal ln of 4 minus 4 times 1 minus e to the minus x when I square this out, because I square the 2 and I square the square root. Ln 4 minus 4 plus 4e to the minus x. So these two cancel out. This gives me ln 4 plus ln e to the minus x, which is going to be ln 4 minus x. I could bring the minus x down and then do ln e, which is 1, or I can just see that when I do ln of e to the minus x, I'm asking what do I raise e to the power of to get e to the minus x? It's going to be minus x. So we're asked to write it in the form a plus bx, and that is actually what I've done. A equals ln 4, b equals minus 1. And as for the domain and range of this function, the domain is going to be the same as the domain of f of x. So x is any real number, but x is greater or equal to 0. And in the range, well, I spent a little bit of time on this. I said I'm going to get out numbers between 0 and 2. But what happens is there's a bit of a symmetry with g of x, and that, for example, minus 1.5 will give the same as 1.5. So in fact, we'll get the same range that we would have for the original g of x. Okay, it's not like reduced or anything, and therefore g of f of x is simply going to be less than or equal to ln 4. So that is my domain and range. Now we're asked to sketch the graph of the function g of f, showing the coordinates of any points where the graph meets or crosses the coordinate axes. This is just a straight line graph. And sorry, I think, was this part C? Let me just check. Yes. So it's going to look something like this. Actually, let's make it look like the gradient is minus 1. So we're going to get ln 4 here, and then we're also going to get ln 4 here. Now it did actually ask for coordinates, so just write 0 ln 4 here, and then ln 4 0 here. Finally, part D says the circle with center 0 minus ln 9 touches the line with this equation at precisely 1 point find an equation of the circle C. So I'm going to demonstrate two ways to do this. There's a really quick way, which I gotta admit I didn't realize when I did it, and there's a longer way. So minus ln 9, maybe it's sort of here roughly. And then here is a circle. Okay, I'm going to make sure it doesn't touch at ln 4. It might do, but my sketch shouldn't illustrate that it does. Okay, now there's a quick way to do this, as I said, and it is to connect the center to the points where it touches, and then recognize that this is a right angle because a radius meets a tangent at a right angle. But furthermore, we know from the equation of the line that this is 45 degrees because we've got ln 4 and ln 4. This must be isosceles, this enclosed triangle here. But what that means is that we've actually got an isosceles triangle outlined. Let me do it in green. This is also an isosceles triangle. But in our case, we've got the radius, and therefore this length is also the radius. That just leaves us this, which is going to be ln 4 minus ln 9, or ln 4 plus ln 9, which becomes ln 36, or ln 6 squared, which is 2 ln 6. So I can now apply Pythagoras' theorem. R squared plus r squared must equal 2 ln 6 all squared. That means that 2r squared is equal to 4 times ln 6 all squared, which means r squared is 2 times ln 6 all squared. No, I can't do anything about that squared. I can't sort of bring it down or anything because it's not the 6 that's being squared, it's the whole of ln 6. And therefore, the equation of my circle will be x squared, and the center is 0 minus ln 9. So x squared plus y plus ln 9 all squared equals our r squared, which is 2 ln 6. Running out of space here. 2 ln 6 squared. That is the equation of our circle. Now, here is another way to obtain that equation that is longer, but this is actually how I did it because I didn't spot that little geometrical idea. So we know that the equation of the circle is going to be x squared plus y plus ln 9 all squared equals r squared. We don't know what r is, but we do know that it's going to intersect the line y equals ln 4 minus x. Remember, that was the tangent. So I can substitute in for y, ln 4 minus x. Therefore, x squared plus ln 4 minus x plus ln 9 all squared is equal to r squared. Now I'm going to expand the bracket. Actually, before I do that, let me just write it out again. 2 ln 6 minus x times 2 ln 6 minus x equals r squared. So this will give x squared plus 2 ln 6 times 2 ln 6 is 4 ln 6 all squared. And then I've got minus 2 ln 6 times x, and then another one. So it'll be minus 4 ln 6 times x plus x squared is equal to r squared. And I'm trying to get a quadratic here. And although we don't know r squared, we do know that there's only one root. So we can basically find the, we can find the discriminant and set it equal to 0. So 2x squared minus 4 ln 6 times x plus 4 ln 6 squared minus r squared is going to equal 0. So this is my A, this is my B, and all of this is my C. So y equals ln 4 minus x, a tangent So b squared minus 4ac is going to equal 0. That means that 4 ln 6 is a minus, but doesn't matter, all squared. Minus 4 times 2 times 4 ln 6 all squared minus r squared is equal to 0. Sorry, did I make, I think I've made a little mistake there. No, I haven't. That's a bracket. Okay, that's okay. So 16 ln 6 all squared minus 8 times 4 ln 6 squared minus r squared is equal to 0. Going to divide through by 8. 2 ln 6 all squared minus 4 ln 6 all squared plus r squared is equal to 0, which means r squared is 2 ln 6 all squared, which is the same as what we had before, and therefore x squared plus y plus ln 9 all squared is going to equal 2 ln 6 squared. All right, it's not a succinct solution, so I might lose marks on it for that, but it is a solid solution. And it's worth comparing it with, well, this much quicker one, but look, it gets us there. Okay, oh, well done on this question. You can see there's only 3 marks and I spent a long time on it, but I've shown you more than one method. Well done.